Now we focus on how to connect to a remote database, get data from there, and eventually want to write back to the database to create new tables. Okay, this is actually basically something we already just mentioned in the slides, so I'm not going to repeat those here. And the two main libraries we are going to use, one high level, one lower level. Okay, and a bit about Neon. So basically, whenever you sign up, you get a free database system. You create a project. Every project for the free tier, you only have one database, which is called NeonDB. And then the default owner user is NeonDB owner. So anyway, that's not too important for us for now. Okay, so to get started, let's install those two Python libraries for dealing with database. So let's finish those, and then we can be good for the rest of today's class. So again, exclamation mark for using the pip command to install packages. Pip install the name of the libraries, which is SQL Alchemy and PsychoPG2 -binary. Okay, so that's, I'm just using the autocomplete function, and then let's see if it can be successfully installed. So it takes some time, but I think it's actually pretty fast, right? So it's already finished installing, I guess, both libraries, which is great. Now, this is just some initial preparation. And we need to connect to the library, the database, right? I mean, for any remote service, typically you will need a few things handy to connect. As you can imagine, usually we need an URL to visit the location of the remote service on the internet, right? And then for database, as you can imagine, it's a secured system. You need the username and password before you can actually do anything. Okay, so let me quickly show you how to do that. And this is for in-class demonstrations. This is what we are going to use. For the database I created on Neon, the username is class_user. The password is DA with Python. Right. So then we're gonna see how we can use that. And before we go further, let me go to my Neon account. So actually, I have created two projects, right? And we're gonna use this project called Retail Data Example, where we have some retail data. Inside this project, this is a dashboard, a lot of things going on. But for you, for today's demonstration purposes, it's not too important for you. But if you later on you create some database on your own on Neon, you will need to do similar things, right? So for me right now, on the dashboard, you can click on something called Connect, and then it shows you a pop-up window. But the most important thing here is something called a connection string that contains all the important information for you to connect: the URL, which is the server address, and also password and username, everything there. So I'm not using the default owner user. Instead, I created a user called class user. So let me switch to class user as the role here. And then what we can do is to look at this connection string. You don't have to do it here, but later on you do your own experiment, you have to do it. So then you copy and paste into the Jupyter Notebook. In the Jupyter Notebook, I believe I have already provided the string here. So as you can see, go to the section, start with how to connect, right? So you will see I included this connection string here. So you can select this connection string and copy it. So maybe I just use Command C because it doesn't allow me to copy by right click. Anyways, so this is the string we're going to use. Okay. Now, I'm going to change it slightly, but before that, in order to connect, remember we have installed the two libraries. One is the SQL Alchemy, and from that library, I'm going to import one specific function called create engine. So we need to create an engine, which is something we can rely on to talk to the database. Right? So this is the function we're going to use, and then we're going to define an engine. Engine, this is the variable to represent the engine for accessing database we're going to use, right? So then the function is simply create engine, and then we need to provide a string as the input parameter. So quotation mark to represent a string, and I'm going to paste the connection string I showed you on a previous screen, which is also in the notebook. Right? But not quite there yet. I need to make a few changes. First of all, see the part before the column. Right? It gives you the word PostgreSQL, which is intuitive because we're gonna access the Postgres database system, but not quite yet. We need to add cycle PG2, okay? Because we need to use this driver that we can use to talk to the database. So this is first changes. Of course, then you have to replace the username. So username is class user for this example. And if you are performing your own project or working with one of our partners for the course, and you need to find out what is the username you can use to access the data. Okay? And password, I need to replace password, right? So remember here it's DA with Python. Okay? And the remaining part is simply the rest of the connection string that tells you the URL or the remote address of the server. Okay, so then this is complete. Just to quickly recap, right? Add cycle PG2 before the column, and then replace the username and password, and then you can try to run it to see if you can connect. For me, it does not return any error, but hopefully you will. I guess like if you make things carefully, specify the password and username, hopefully things will run smoothly. Let me know if you encounter any problems. Okay. So now we have created an engine, right? And then from that point on, we can rely on this engine to connect to the database. Okay. So let's see how we can move on. Now, I don't intend to run this block of code. It's written in a Markdown format to explain an alternative approach. So instead of using a single connection string, we can actually break things down. It's longer, but this approach is actually a bit more, informative, right? So it's easy to visualize. So basically, we're specifying the driver, username, password. So we're breaking the connection string into multiple parts, right? If you want, you can copy and paste this block of code into a new cell. It will eventually give you the same thing, which is an engine created by SQL Alchemy. And from that point on, you can do this exactly the same thing for connecting to the remote database. Okay. Now, we have created the engine. The next step is to actually test the connection. Okay. So how do we test the connection? Remember, we said that for our purposes, most of the time we'll let pandas, the Python library, to talk to SQL Alchemy, the high-level library for dealing with databases, right? So we need to import pandas again. Import pandas as PD, same thing as before. Now, we're going to have one simple code called panda pd.read SQL. And then inside this command, we're going to write a simple SQL command. Okay. It's very simple. We're going to select. Select is where we're going to, how we can get data from the library, right? Select version is a function of the database system that tells you about the version of the database. And SQL queries always end with a semicolon. And that's the SQL command we want to use to read data from the table. So that's why it's called read underscore SQL, right? And then it's not enough, right? Because we need to send things through the SQL Alchemy engine, right? We have created an engine, so the engine will be part of the The variable engine is the engine we created for all those database queries we're going to use, right? So if we do this, and then we can talk to the database through this engine we created, and then we'll try to see what result is returned by this line of command. Let's see. Sorry. I guess sorry, the SQL command is wrong. Select, not selection. My apologies. Now, it's actually a data frame return, because whenever we're using Panda to talk to the database, it always returns some data frame, because Pandas is all about data frame. But data frame here is very simple. It just has one row and one column, and the content of the data frame is simply the version of the Postgres system used by this remote system. Okay, so it's actually 17.5 as the version of the PostgreSQL we're currently using. So nothing complicated, right? So we just use this command to test the connection, and we haven't done anything concrete yet. But next step is that here we have some description of how data is organized. So that's basically the database as a building, right? Schemas as floors and tables as a room, this kind of analogy. Now, here in this notebook, we're going to use two schemas. One is the public, the default schema for every Neon database. But then I created another schema, which is called 0712 underscore schema. This is something I created. It only works for my database, used for in-class demonstrations. If you are doing some experiments, you have to create your own schema to test things out. But for now, you can use the same schema. And then we're going to read data from the remote database, right? So at this point, let me quickly go to the Neon website here to show you what kind of data is actually available in my database. So this is the dashboard. Actually, this is dashboard after I entered the current project, right? And then look for tables on the left panel. So you can see there's a entry called tables here. Let's click on that. And you can see I have two tables under the public schema. So here's a drop-down menu. You can switch between the different schemas. You can have tables on each schema. Right? So here you have the public schema, and then you have orders and products as two different tables. Right? And you can actually preview the content of the tables. For example, click on orders, and then you will be able to see the content of the orders table. It's nothing too different from a data frame, right? Just a table and several columns, ID of each order placed by customers, a date of the order placed, and then customers' information like name, country, state, things like state of inside the country or provinces inside the country, right? And city, region, shipping mode of that order, name of the product ordered, and this sorts of things, right? And the other table is about the product. That's the information about the product carried by this company. By the way, I think this is a company. I think this is probably I forgot the company, but it's a real world data set I get from Kaggle. Anyways, so we have two tables, right? So now the next task is that we know that those two tables, they live in the database. Now, we're doing some programming tasks, either just doing some research or maybe imagine that you're developing an app, right? So in our codes, we want to get those tables from the remote server, and then we want to, because we're dealing with pandas, right? We want to convert those tables into data frames. Data frames and tables, they're really similar things. Right? So it will be ideal if we can get a table from the remote server and convert that into a data frame. And then from that point on, we can handle the data in all those methods we have walked through in our previous classes. Okay? So let's see how we can do that. And the main function we're going to use is called read SQL table. That's just to read a table from the database and convert it into a data frame. Okay? As several import arguments is required. First of all, we want to get the name of the table, and then we need to specify the engine we connected, because that's where the information like the location of the server, password, username is included. And then we want to specify from which schema we want to get the table from on the remote server. Okay, so those are the several important things, and let's get started. So we're going to do, we have already imported the pandas library, right? So now we can just use this pandas.read SQL table. Okay. You know, with table in the end for this command, what we are doing is really to convert the remote table into a data frame. Okay. Now, what do we have here? So we need to first specify the name of the table on the server, right? So we see orders and products. Let's first deal with orders. Okay. And then the second argument will be the engine. We just enter engine because that's the engine we created. Okay. And the last one is to specify from which schema do we want to get the table. So it's public. Okay. And then let's see what we have. So let me run this command. It doesn't take long, but as you can see, we got a data frame, right? If you go back to compare this data frame from this orders table in the database, you will see that they are exactly the same data frame. Of course, it's actually very long. You have more than 8,000 rows, so it doesn't display everything because of the limited space here. So let's, instead of display the whole table, let's give it a name. Let's call it df _ orders. So that's the name of the data frame we want to use for this data frame we obtained from the remote database server. Okay. Now, what we can do is that, first of all, let's do this. Let's do df orders. That's the name of the data frame. Let's do use the .head function, right? That gives us the first maybe 5 rows. Let's look at this. So just some preview. So things look actually okay, right? And after that, if we want, we can do things like df orders. Remember, we mentioned this function before for info to get some information of a given data frame, right? So, I mean, here it's just showing us the name of the column and how many rows, how many values contained in each column. It's more than 8,000. And, you know, the task is completed, right? One major task for today's class is completed. So basically, we have a table on the remote server and use this one line command to convert that into a data frame. Okay? So things are pretty much done for this part. And questions for now? Okay, so let's let me delete the last line of comments and let's run it again because I want to quickly show the table again. Okay, so just a data frame of orders, right? Every order has an ID and date of the order, and customer name, and the location of the store where the order is placed, right? And then a bunch of other information. There's also like how many units of the product is actually purchased. There's also a discount. I think the discount is in dollar value, like 50 cents is deducted from the total price, right? And feedback column is whether the customer provided some feedback, like online review or something after placing the order. Anyways, that's the data frame, right? So it's very simple. So for the purpose of getting data from databases, it's already done. But let's actually go one step further. Maybe later on we're gonna talk more about visualizations, but let's already get started from doing some quick visualizations to see how once we get a data set, what we can do, okay? So, first of all, we want to do this. Let's say DF orders is the data frame we obtain, right? And there are many different columns, but for now, let's focus on the column called ship mode. It will tell you what is the ship mode for a for each order in this data frame, right? So let's just do this for now. So we just take the ship mode column to see what's there, right? As you can see, there are different ship modes like economy, economy plus. Again, as you can imagine, for extra money, you can get the order to be delivered sooner, right? But there's a lot of rows, right? Because that's a column of more than 8,000 rows. So let's try to do some aggregation. What we want to do is that, one thing we can do is that, for example, some of the orders are under economy shipping mode. Maybe let's count how many orders are delivered through the economy shipping mode. Right? How many orders are by the economy plus shipping mode? Right? We want to do this sort of things to see that what's the frequency of each shipping mode. It's actually quite simple. What we can do, I forgot if we have done this before, but it's actually quite simple. We're going to do this column and then followed by a function called value counts. This value counts function can be applied to any column of a data frame. Right? So we have a column of values of different shipping modes. We count the occurrence of different values in that column, and let's quickly see what we get. A simple result that's also looking like a data frame. Right? It's only one column, so that's essentially something we call the data series because there's only one column in the data frame. So, anyways, as we can see, we have 4 different shipping modes. Right? We only saw 2 when we were trying to preview the data because there were too many records. But now, if we do a value count, we see that there are 4 distinct values in that column. Economy, economy plus, priority, immediate. So I guess from more economic version to the more, more pricey version, right? So anyways, we know that there are 4,862 orders delivered through economy mode, and similarly, all those numbers you see here, they are the number of orders placed under each of those different modes. Right? Now, this is how we can get those counts, right? So now the next step is that we can do a quick chart. This line of command already returns something like this data frame, but it's a data series, right? So if you look at the type of this result, you will see that the type is called pandas series. Pandas series are just essentially the same thing as data frame, but this only has one column. Okay. Anyways, what we can do if we have a pandas series is that we can immediately try to plot the distribution of values. For example, one thing we can do, it's already in the comment I included above, but let's try to implement it. So dot plot. So we're going to focus on the data in this result, which shows you the frequency of shipping modes for different orders, right? And then we're going to plot it to do some visualization. So what is the kind of a plot? So the type of plot, let's say we do a pie chart that shows you the percentage of order delivered in each mode, right? And then the second argument we can use is called auto PCT. PCT is the percentage. And this is actually not so important, but it specifies the format of the display, right? So we start from a percentage mark to show that we're specifying some format. 1.2f, it means that 1 represents an integer percentage followed by 2 decimal places. For example, 10.35%, and this is one of those formats. And eventually we want a percentage mark. So when you use only 1 percentage mark, it's just to represent a special symbol in Python, but so that's why you need to use 2 percentage marks to represent one single percentage mark to be displayed. Anyway, that's not too important. And then we can already do the chart. Just very simple, specify the kind of the chart as pie chart, and then some display controls. and then let's try to show it, right? So it's a nice percentage. I mean, nice pie chart to show the percentage of the different shipping modes, right? So sometimes we want to use something like a title. So we can specify one more argument, which is title equal to, let's say, distribution of ship modes. And nothing will be too different except we have a title. Okay. All right, so that's a quick visualization. And now, before the second break, let's move on to just one last task. Let me delete this command, but maybe not completely delete it. Let's revert it into the value counts, right? So let me run it again. So we're back to this value count of the shipping modes for different orders. Now let's do another quick visualization. Let's say we plot a bar chart. Right? So this time, this chart, we're gonna do a bar chart. So let's say kind equal to bar, right? And then what we can do is that we don't need to do anything actually, I believe. But let's just run this command, and then it shows you a bar chart, right? So that shows you how many orders are placed under each of the delivery modes, which is already there, but we can make it slightly nicer. For example, as before, we can do a title, right? Title equal to distribution of shipping modes. Right? So run it again. So now we get a title on the top, right? And then sometimes when we want to add, labels to the horizontal and the vertical axis to just explain what the axis represent, right? So for example, we can do X label equal to, so let's just specify that it's equal to something called frequency, right? Maybe not frequency. X label is the shipping modes, right? Because horizontally we have the shipping modes. And then let's run it. Nothing will be too different, except that in the bottom you see that explain that economy plus those values represent ship modes, right? That's showing up on the x-axis, which is the horizontal part of the chart. Okay, we can also give the y-axis a name, which is y-axis can be frequency, right? Because y-axis, if you look at the height of the bars on the axis, they will be representing, how many orders were placed under each of the shipping modes. Let's run it. So on the left, you see that we're explaining that the height of bar is representing the frequency of orders placed on each of the modes. So remember, on the remote server, we have two tables. So let's apply the same procedure to the other table. So we have the products table. Imaginably, this typically represents all the products carried by a retailer. Okay? And then let's see what we can do. So basically the same thing. It's the same database, right? Because it's the same database, we don't need to use a different engine. Like we create an engine for connecting to that database, but now we're going to read another table. But this time the engine is already there, so we just need to apply the same command to create a new data frame. So the new data frame from the other table, let's call it df products. Okay, and then the command here is already showing up by the AI assistant. So let's use the tab key to complete it. So again, read SQL table, which is to get the table from the database and then convert it into a data frame, right? And the first argument, product, is the name of the table on the database. The second argument is engine. That's where we can have the information of how to connect to the database. And schema, again, is public, because those two tables, very quickly, back to Neon, those two tables are under the public schema. All right, so, and then after we obtain the second table, we can use this head function to view the first few rows of the new data frame. So let's see. An error. So let me quickly see what's going on. Okay, so I think maybe I got timed out. So let's see. Okay, so this time I don't know how something strange happened. So anyways, so this time it's okay for running this command. And let's df products, the data frame name, and let's preview it. Okay, so first few rows of the product table, nothing fancy, right? So just the name of product and which segment is the product belonging to, like, and category, those are just the information on the organization of the different kinds of products in the database, like subcategory, unit price, and also the cost of the product. So, I mean, that's just another table, right? Nothing, I guess nothing fancy. Now, with those two tables, let's actually quickly look at them. Okay, so the product table, of course, have the product names to show the different products they carry. And previous table is the order table. And this order table also has a column called product name because we want to know what product is ordered in each order, right? So one observation is that they both have the common column called product name. And so this is a typical, operation that we're going to cover for databases. Many of you may know sometimes we want to merge two tables, which is called join for database operations. Here, we're going to focus more on Python. So let's see how we can join those two tables based on a common column using pandas instead of instead of database. We're going to do some merging operations or joining operations if it's in database terms, right? So we're going to do a data frame called order, df orders, and then dash, let me use PI, product information. Right? Orders, records with the information of products, with product information. And then we're going to do a merging, pd pandas dot merge. And then we're going to merge two tables, right? And then we just first specify the first table. The first table showing up in this argument list is always considered the left table, right? First one is left, and the second table is df products, and that's the right table. Okay, that's the second table considered the right table. We're going to merge them, but how do we merge, right? So we need to specify the common column. So on equal to, that's specifying the name of the common column. On equal to, here it's product name, right? Remember, both tables have this common column called product name. So that's how we can specify on which column we are merging the information, right? And then there's a final argument called how, and as you can see, it's very intuitive. So we're going to say left. So we're doing a left join, right? Left join means that we keep all the rows in the orders data set, right? And then we match information from the right. Here we're mostly interested in price, but then alongside price, we're going to add a bunch of information about the specific product being ordered in any of the records in the orders table, right? So if we run this command, we're supposed to go through if there's no errors, and then let's just preview a few rows. Let's see if we get an error. There's no error, that's great. So let's zoom out a bit. I mean, the observation is that now becomes a wider table, right? Because from the first column up until, I think, feedback, that part is the orders table, right? And then based on the product order, we're adding information from the second table, right? The category of the product, and unit price, unit cost. Right? So it becomes a wider table. So sometimes it's going to be useful because eventually I want to focus on the information from both tables. Okay? Let me know if you have any questions. If not, let's do one more thing. Okay, so let's look at this table, and then this time let's focus on this column, which is the price. It's a bit small. Let me make it larger. Unit price, the price of the product ordered, right? And let's also focus on quantity. How many products are ordered, right? Quantity and price, that gives you the total amount, dollar amount of the money spent on this order, right, for that product. And then there's discount, right? So if we have some discount for a customer in an order, we just subtract the discount from the regular price times quantity, and that's how we get actually. That's how actually we get the total revenue for this order, right? So let's add a new column. So we have this DF orders PI, product information. Right? So let's do several operations. Eventually, we want to get a new column. Let's say sales, or maybe let's call it revenue to make it more actually concise and informative, right? So how do we do that? So revenue is typically, let me just use the tab because the AI assistant is already guessing what I'm going to do, right? Quantity, the quantity column, shows how many units you bought, right? And price column shows you the unit price. So do the multiplication, and you will get, the total price, right? Total price, or total revenue collected from that order. But let's actually do something about the price. So let me put the price in a pair of parentheses. I'm subtracting DF, orders, product information, discount. Let's say that I guess the discount should be for the unit price, right? So for certain orders, maybe we give up a discount on the unit price, so the actual price is lower. Right? The regular price minus discount is the actual price, and then multiply by the quantity. And then we assign it to a new column called revenue, as we are supposed to get the same data frame but with a new column of revenue. So let's see if it can go through. Some error. I guess something wrong about the price. So I don't know if it is it called price? Unit price. So the column name is a unit price. So I messed up with the. Actually, it was from AI. So I guess sometimes using AI will cause those little problems. So we'll still need to be in the driver's seat, right? Okay. Now things went through, and just scroll all the way to the last column. Now we can see that for the last column here, we have the revenue. Like intuitively, we collected $43.50 for the first order. That's the meaning of the last column. Okay. Now, that's I guess usually some kind of meaningful operations. And next, I want to actually visualize the distribution of revenue. I mean, for some orders, we collect more revenues. For some orders, we don't collect much revenue, right? Because maybe only one unit product and the price is very cheap, and in those cases, we don't collect much revenue. However, let's try to actually do some visualization. This time, let's do a box plot. Not only want to see the revenue distribution, but we are also going to show the distribution based on the shipping mode, right? So remember, we have economy plus, priority, and immediate as the different shipping modes. So let's say what is the revenue collected for orders under each shipping mode, right? So things like this may be meaningful because we want to see, if the total price is higher, customer tend to use a faster or cheaper or a more expensive shipping mode, right? So let's do that. So let's see what we need to do here. So we're gonna do first the name of the data frame, right? And then we're going to do a box plot. So the name of data frame followed by a function. Here's the box plot function. And that typically will give you directly some visualization based on this data frame. Okay, so it's a very convenient way by Python. So inside this function, we need to specify which column we are interested in. So revenue, right? So let's look at the distribution of revenues. So unlike what we have done previously, I'm actually creating multiple lines inside the parentheses, which is allowed by Python. So, and then, but it's the same if you want to include all of them on the same line, right? The second argument is the by keyword argument, so it's going to be ship mode. So I want to visualize the revenues. We have different revenue values, right? But then by equal to ship mode means that I want to divide all those revenue values based on each ship mode, right? So each ship mode, I want to see what are the distribution of the revenue collected on those orders, say under the economy shipping mode. Okay, so this is the second argument, and that's pretty much it. So let's just try to run it. Okay, and this is what we call a box plot. I'll quickly, some of you may already be familiar with this kind of chart, but let me quickly explain in case this is the first time you encounter this kind of chart. But before that, actually, it's not very easy to visualize, right? Because, the box part in the box plot is actually very narrow. Instead, we have a lot of those individual points representing outliers. So let me set the range of the vertical range. So let's set after the function ends, basically we are getting some result, right? And from the result, we want to do some control. So dot set underscore y lim. That's set the limitation of the y range. As you can see, the y range, the values of the revenue spans from close to 0 all the way to over 6,000. It's actually a bit too much. Let's set it to from 0 to 500 so that we can get a cleaner look. You have to experiment with those values, right? For example, 500 is somewhere here, so that will allow us to have a better look at the boxes. So let's take a look. So those are the box plot, right? So let me quickly explain the meaning. So what does this mean? Of course, we have 4 shipping modes, right? And then because we focus on the revenue column, if we focus on economy, those are all the orders use the economy delivery option, right? And then the middle green line here is the median. So that's the median. As we can see, for economy, the median value is maybe 120, about 120, right? It means that the median of the total revenue collected from orders on the economy shipping mode is about $120. Okay, and then we have the actually all those percentiles, right? So I'm not sure I completely get the idea, but I think this is median. We know it's the 50% percentile, right? So here in the bottom of the box, we have the 25% percentile, right? So here it's about $50. So like about 20% of the orders have a revenue less than $50. And on the top, this is the 75% percentile, right? And the value is maybe, let's say, 320, okay? It's like about 70% of the orders under the economy shipping mode have a total price below $320. And there's some concept, it's not so important, but just in case it may be useful to some of you. IQR, intra-quartile range, is the height of the box between the lower end and upper end, right? And then there's some kind of whiskers, like something like an antenna or whisker that extends from the bottom, goes to the above, and then that's actually, I want to reach out more from above 75 percentile and 25 percentile, just to showcase that there's still considerable mass above 70% and 25%, right? And then we want to I remember it's actually, the length of the whisker should be 1.5 times the length of IQR, the intra-quartile range, right? To see, just to go above that range, 70 percentile, 75% percentile, and then to see where is the location of the last data point, right? If before actually you go out of 1.5, height, length of the IQR. It's not super important, but just some background information. And above or below each of the whiskers, you may have some outliers. Right? Anyways, just some background information here. So let me remove it. So what is the conclusion we can, the more important for us, the thing is for us is to try to get some insight from the visualization, right? If you look at those box plots showing you the distribution of the data across the different shipping modes, the question is that what kind of conclusion can you make? What kind of research questions or what kind of insights you can possibly get or answer based on a chart like this? Well, remember, those are the distributions of the total price under different shipping modes, right? For example, one question I can ask is something like, for example, let's say a certain customer chosen priority compared to other customer may have chosen economy, right? Is the decision of which shipping mode to use driven based on the total price? Right? Intuitively, it's possible that if I'm already spending $1,000 on buying products in my order, maybe I don't mind add $10 to choose the more premium mode of shipping, so that it will be arriving sooner, right? So, looking at this, what conclusion can we get? Well, I would say that look at the boxes. There's differences in terms of their position vertically, right? But not such significant difference of the distribution, right? The top end, bottom end, the medium, of course they're different, but then they're not so much different, so much different from each other. So one possible conclusion is that maybe sort of the decision of which shipping mode to use maybe not driven or not that much correlated with the total amount of money you spend on your order, right? So this is something we may possibly get from this kind of plots. Right? So, well, of course we're doing some tasks, but more importantly, what we want to do is actually to see what kind of conclusion we draw. But this kind of conclusion has a bit of a caveat because of one small detail regarding how the data is organized. Right? If you go back to look at the records very carefully, you will see that actually inside the order column, the values are not unique. Right? Order 1, for example, may appear twice. Why it may appear twice? This time it's not because of duplication. Right? In this example, we can see that order 1, in the first row, we have product 1. And in the second row, this again order 1, but this time we have product 2 inside order 1. So it means that every order can possibly have different products combined, right? In that case, because we can only include one product in one row to make things simple, and so we may need to repeat the order in the order column multiple times, right? So if this is what it looks like, let's say there's no other rows, and then we know that order 2 only purchased product 3. Order 1, however, purchased both product 1 and product 2. That's the meaning, right? So when we were doing this visualization, actually, we didn't consider the possibility of an order showing up multiple times in the order column, right? So it turns out we calculated a total price for product 1 in order 1, and the total price of product 2 in order 1, they are treated as separate records, separate values, right? However, the shipping mode decision may not be completely driven by the total price of a single product in one order. It's usually driven by the joint price, total price, combining all the orders purchased in one order. So there's some complications. So the main idea is that this kind of caveat, so even sometimes we have developed some visualization and reached some conclusion, we also always need to check the data very carefully to see if the conclusion is correct, right? For this time, in the interest of time, I'm not going to proceed further to fix this issue. But then if you're interested, it's left as a possible exercise for you to perform to see in a more rigorous way to test if the use of shipping mode decision is actually driven or correlated with how much money you pay in total for your order. Okay. Questions? All right. So one last thing for this notebook. Okay. So one last thing for this notebook. Let's try to save the data frame back into the database, right? Because so far we have been focusing on how to read a table from the remote database. Okay. Now, to conclude this class, especially to conclude this notebook, anyways, let's try to complete this, right? So this time we're going to look at this data frame called df orders pi. Okay, so let's try to run this command just to recall that this is a new data frame we have created, right? So this is actually a table we created by merging two tables. It's not on the original database. So let's see how we can do that. So we're going to make use of this data frame. And what we can do is that we're going to do this data frame name and to SQL. It means that we are converting this data frame into SQL language format and then send the SQL language back to the server to create a new table. Right? So let's see what we can do inside this function. So we're going to specify the table name you want to use in the database. So it's going to be orders, products. And then here, I want to use my name following the order products underscore. And on your end, you can use your initials, your name, or anything that is different from my end, because otherwise we may create different tables of the same name. So whoever developed the table later will be overriding the table created by another person, right? So if you are doing the same thing on your end, choose a different name. It's preferred that you use order, products, and then your name or anything, somehow unique, right? So this is going to create a table on the remote database. Okay, so let's still use the engine because it's the same database, right? And let's use index equal to false because, just like how we write to a CSV file, right, the indexes of the row starting from 0 by default will be treated as another column. Typically, we don't want to do that because the index is just some way for us to access the data in a data frame. They are not that meaningful, right? And then we decide what we do. If the table already exists in the remote server, what do we do? There are several options. You can add your table to the existing table, then use append. But here, let's do replace, right? If this table with the same name already existed on the server, just replace it by this new one you are creating. And finally, do the schema. Schema is equal to, we have been using the public schema, but I set up access such that public schema cannot be altered by anyone other than the database owner. So here we are having a class user as the username, but it's not the owner. So let's use 0712 underscore schema. Okay. And this is a schema I created to which we do allow access by the class user, the user with this username. Okay, so I think should be okay. Let me try to run it. Okay, so sometimes this kind of strange errors show up. Let me try to do it again. So this time it's okay.